Okay, so we want to solve the quadratic equation 3x squared equals 2x minus 3. We know it's a quadratic equation because we have an x squared. And I told you to use the quadratic formula, which if you recall is, here's my quadratic formula, I'm going to write it over here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Very important that you memorize this formula. You must know the formula by heart so that you can use it to solve a quadratic equation. The first thing we're going to do is get our equation into standard form by setting it equal to 0. We'll subtract 2x from both sides, and we'll add 3 to both sides so that we get 0 on the right side. So this will give me 3x squared minus 2x plus 3 equaling 0. And I'm going to write down what my values for A, B, and C are. I always do that when I want to use a quadratic formula because I know that I have to substitute those numbers into the formula. And the A is the coefficient of the x squared, which is 3. The coefficient of the B is the coefficient of the x, which is negative 2. Don't forget that negative is part of its coefficient. And the C is the number that stands alone, which is 3. And therefore, we're going to, by substituting this into my formula, I'm going to get x equals negative. Now, wherever there's a letter, I put a parentheses and fill in the parentheses with a proper number. So in this case, in place of B, I'm putting in negative 2. Then there's a plus or minus. And then it says the square root. Okay, and then the first thing we have is a b squared. So here's my parentheses for the b, which is negative 2 squared, minus 4. And then I have a parentheses for the a and a parentheses for the c. So it's negative 4ac. So it's negative 4 times 3 is the a, and 3 also happens to be the c. And this is all over 2a, which is 2 times 3. So step 1, decide what your A, B, and C is. Steps 2, stick it into the formula. Substitute those numbers into the formula. Step 3, we're going to simplify everything. So the first thing we have is a negative 2, which is a positive 2. And here's where we're really going to have to be careful. We have this number inside the square root. Let's get that correct. First of all, we have negative 2 squared, which is a positive 4. Negative 2 times negative 2 is positive 4. Then I have minus 4 times 3 times 3. So 4 times 3 is 12, times 3 is 36. So this is minus 36. And 4 minus 36 is negative 32. And that's all over 2 times 3, which is 6. And we've simplified it a lot, but the thing that we really have to work on is making sure that we simplify the radical. That's always going to be the work that we have to be very careful about. Well, let's do that over here on this side. Let's look at the square root of negative 32. Let's simplify that first. And we know that if we break it up, first of all, there's going to be a negative 1 because this is negative. And the 32 I can break up into 16 and 2, because we want to pick the largest perfect square that we can. And even though 4 goes into 32, so does 16, so we're better off using 16. And therefore, this becomes the square root of 14, which is 4, the square root of 2, and I If you want, you can put the I in front of the square root and write it 4I radical 2. It doesn't matter which way you do it. So that this will become 2 plus or minus 4I radical 2 all over 6. And then I look to see if I can reduce this. And I have these 3 terms. I have the 2 here, I have the 4I radical 2 here, and the 6. And there is a number that goes into all 3 of those, and that's a number 2. So 2 divided by 2 is 1. Don't just drop it. You're dividing 2 by 2, it gives you 1. 4 divided by 2 is 2, and 6 divided by 2 is 3. So I can get my answer as 1 plus or minus 2I radical 2 over 3 in simplified form. I see it's a complex number because I ended up with a negative inside my square root. Sometimes, if you recall, we write our complex numbers as separate pieces. So I could write the 1 over 3 plus or minus 2I radical 2 over 3. Sometimes the I, instead of putting it in the middle there, they put the I at the end. So it would be 2 radical 2 over 3 times I. This would be in what we call the A plus BI form. But notice this was quite a hard problem, which involved a lot of work, but the hardest part of everything was simplifying that radical. So that's why we had spent time learning how to simplify things with radicals and fractions, etc., because we keep using that information. Now, does anybody have any questions? Okay, so then we're going to go back to the last topic that we had touched while we were on Tuesday, and that's what we started talking about, something called conic sections. So I'm going to erase this and we're going to go on with our conic sections. In the interim, I'll still leave that formula on the board, but I probably will erase it in a little while. We're going on to graphing of quadratic equations. And we said when we graph quadratic equations, we get one of 4 different shapes. The shapes were A, the circle, B, the ellipse, C, the parabola, and D, the last one, is called the hyperbola. These are what we call the conic sections. And we discussed why that term was used, but it's not important to know why it's used. We just have to know that this is what it stands for. And what we also did is we started talking about the circle, how to recognize that an equation is the equation of a circle, and how to graph the equation if we have such an equation. Okay, so let's go through the things that we talked about the other day, and we'll talk about the circle. Now, you may recall that what we said is that the standard equation for a circle is x minus a squared plus y minus b squared equals r squared. This is what we call the standard format of the circle. And the A and the B are the coordinates of the center of the circle. In other words, I look at the numbers that are inside the parentheses with the X, that'll give me the A of the center. And the number that's inside the parentheses with the B, with the Y will give us, which is called the B, will give us the Y of the center of the circle. Notice, but it's just the opposite signs. If this is -2, then the A is 2. If this is +1, then B is -1. You switch the signs. The radius of the circle is the square root of the number that's on the right side of the equation. So R is the radius. And we can use this equation, this format, to write the equation of a circle. And we could also use the format to figure out what the circle looks like. So question number 1, if I tell you that I have a circle whose center is 0, -5, and its radius is 4, then I can write the equation of the circle by replacing the A with 0, because the center gives me the A and the B, and the B with -5. So my equation will become x minus A squared, which is x minus 0 squared, plus y minus -5 squared, because my B is -5, equals r squared, which is 4 squared. And of course, I can simplify this. X minus 0 is just x, so this just becomes x squared. Y minus -5 becomes y plus 5. And 4 squared is 16. This is a circle whose center is, well, the number next to the X. There is no number, it must be 0. The Y is -5 because we always switch the sign. So it's 0, -5. And the square root of 16 is 4. So my radius is 4. It actually happens to be a circle whose center is on the y-axis because the A is 0. That's on the y-axis. It's 5 down, and we have a circle. The general look of the equation of a circle will always have in its equation an x squared and a y squared. And the numbers in front of the x squared and the y squared, notice this is y, it's in the parentheses, but if you would remove the parentheses, you would get y squared. So we have a x squared plus a y squared. Both of those coefficients are 1. That, when we're looking at an equation, we'll recognize that what we have is a circle, even if they don't tell us that, by that feature. Now, what do we have to do? Well, here we started with a circle and we wrote its equation. I could have the opposite. I could give you the equation and ask you, what does the circle look like? What is the center of the circle? What is the radius of the circle? So let's try something like that. So let's say I gave you this equation. Give you a different equation. Suppose I gave you this equation. X plus 2 squared plus y minus 4 squared equals 36. Could you tell me the center and the radius? And the answer is yes. We certainly should be able to figure out what the center and the radius of the circle is. Remember, this number, the number next to the x, gives us the x of the center. Since this is plus 2, my x is going to be negative 2 because it has to be the opposite sign. This is y minus 4, so my y of my center is going to be positive 4. Again, opposite signs. So here's my center. This number always has to be a positive number, and the radius of that circle is always the square root of that number. The square root of 36 is 6. If I wanted to sketch this circle, here's what I do. I'd start at the point negative 2, 4, which is 2 to the right and 4 up. Now remember, I would be doing this on graph paper that would have these lines going up and down. And what you do is since your radius is 6, from that point that's the center, you go 6 in all 4 directions. 6 to the right, 1, 2, 3, 4, 5, 6. I'm just estimating. 6 to the left, 1, 2, 3, 4, 5, 6. 6 up, something like that, and 6 down, something like that. And here would be my circle. You'll have to, since I don't have a good graph board, I'm not getting a very perfect circle, but that's how you would be able to, looking at the equation, figure out its center and radius. But there is a little bit of a problem. Let's look at this equation here. I'm going to erase this. Suppose I gave you this equation. X squared plus y squared minus 8x plus 14y equals negative 61. I'm giving you an equation which is obviously a quadratic equation because it has an x squared and a y squared. As long as it has one of the variables, at least one of the variables squared, it's quadratic. And it actually has, if I look at just, I forget about anything else, but just look at the x squared and the y squared terms, I have this x squared plus y squared. That tells me it's a circle. In any case, they said find the center and the radius, so it must be a circle. So how do we do this? Where it's not written in standard format. It's not written in this basically factored format with parentheses, but everything has been, the parentheses have been opened up. They did the x minus a times the x minus a, and they collected all the like terms. But we can't look at it this way and tell right away what the center and the radius are. So I'm going to give you a way of putting this back into its standard format so we can tell its center and radius. So here's what you do. First of all, you put your x terms together. So we have an x squared and a negative 8x. And leave yourself a space. Then you put the y terms together. So you have a y squared and a 14y. And leave a space. Any number that doesn't have an X or a Y, anything that's just a plain number, has to come to the right side of the equation. In this case, it's already there, so we don't have that problem. I'm going to probably use my calculator a bit, so here's what we're going to do. If you recall, when we learned how to solve quadratic equations, we learned how to do something called completing the square. When we completed the square, we started out with two terms of a trinomial. We'd be missing the third term, and we figure out what the proper number is to add to it to make it a perfect binomial squared, and then we put it in the factored form. Well, we're going to do the same thing here, not only for the x's, but we're going to do it for the y's as well. I'm going to do this with different colors so you can see what we're doing. So first, completing the square for the x. Remember what you do. You take the number in front of the x term, which in this case is -8, and divide it by 2. That gives me -4. Then you multiply that number by itself. -4 times -4 is +16. You add 16 to make this into a trinomial x squared minus 8x plus 16, which is a perfect square. But since I added 16 to the left side of the equation, I have to add 16 as well to the right side. I do the same thing with the y terms. This is y squared plus 14y. I take half of the 14, which is +7, and square it. That gives me plus 49. But I added 49 to the left side. I have to add 49 to the right side. And then what I'm going to do is I'm going to write these things in their factored form. X squared minus 8x plus 16 really means x minus 8 squared. Remember, the number that goes in the parentheses is always half of this number. With the y's, it's going to be y plus 7 squared. That's what y squared plus 14y plus 49 equals. And this, I'll just figure out by adding it all together. So I'm going to get -61 plus 16 plus 49. Couldn't do it in my head, but I'm not. And it all would add up to a +4. And now I have my equation in standard format. X minus 4 squared plus y plus 7 squared equals 4. And therefore, I can write my equation. We can write the center and the radius of this circle. The center is going to be +4 and -7. And the radius is going to be the square root of 4, which is 2. So by completing the square on both the x's and the y's, I was able to put my equation back into what we call the standard format, and then we were able to find the center and the radius. Okay, I'm going to give you one to try while I take attendance and see if you can do that. Okay, I'm going to have to erase it. Can I erase this? Okay, nobody objected, so let's erase this, and I'll give you an example. Here's my equation. X squared plus y squared minus 2x minus 2y plus 1 equals 0. And here are your choices for the right answer. The R equals 1, the center is -1, 1, or R equals 1, and the center is 1, -1. The radius is 1, and the center is 1, 1. The next one is the radius is 1, and the center is -1, -1. Okay, see if you can work this out and come out with the right answer. Put the equation in standard format, and then figure out the center and radius. I'm going to take attendance while you're doing that. The answer to this question using the method that I just taught you. We're going to start, I'm going to work it over here. We have that x squared. I'm going to rearrange the terms. I'm going to put the x squared minus the 2x and leave a space, plus the y squared minus 2y and leave a space. And this 1 I'm going to bring to the other side because I want it equal. I want to get it on the other, have only the letters on the variables on the left side. And then I'm going to complete the square. So I have x squared minus 2x. Taking half of the -2 gives me -1. And -1 times -1 gives me +1. I have to add 1 to the x squared minus 2x to make that a perfect square. So I'm adding +1 on this side as well. Notice that's going to make this x minus 1 squared. The coefficient on the y is the same. This is a -2y. Again, when I divide the -2 by 1, I get -1. And again, -1 times -1 gives me +1. So I have to add 1 to both sides again. And this gives me y minus 1 squared. And when I add all these up, I get that the x minus 1 squared plus the y minus 1 squared equals -1 plus 1 is 0 plus 1 equals 1. I've now put this equation in standard format. Okay, I can now read what the center is. The center of the circle is going to be the numbers that are inside the parentheses. The number inside with the x is -1, so the x value is +1. Remember, you change the sign. The same thing with the y value is also going to be +1. And the radius is going to be the square root of 1, which is just 1. And if I look at it, that has to be choice C. How many people were able to get choice C as their answer? Anybody got that answer? So we have to be able to put our equation in its standard form so that we could figure out the center and radius. Okay, and that's basically all you have to know about the circle. Of course, once you know its center and radius, you could then say, oh, I could draw that circle. Let's say I want to draw this circle. So here's my graph. We just figured out that the center of the circle is 1, 1. So it's 1 to the right and 1 up. Here's my center. And the radius is 1, which means I have to go 1 in each direction. 1 to the right, 1 to the left. 1 up, 1 down. And here's my circle. It's a little circle because its radius is 1. But once you know the center and the radius, then you can figure out what the circle looks like. Okay. Let me mention the examples for this are really not covered too much in Delta Math. Therefore, I want you to make sure to do the examples that are on the practice sheet for chapter 9. I already posted it on Blackboard. Look at the examples that you'll have to be able to do after today's lessons are examples 1 through 5 and 10 through 17. We are now we've covered the questions 1 through 5 because those are the circle questions. We're now going on to the next of the kind of sections that we're going to talk about. And that's something called an ellipse. Remember, I've given you the answers to these, so check your answers after you do the problems. We will go over those on Tuesday. The next type of example we're going to talk about is something called an ellipse. And we mentioned that an ellipse is an oval shape. Sometimes it's flattened. It's sort of a flattened circle. It could be flattened horizontally, or it could be flattened vertically. The only types of ellipses that we're going to be studying are those that are centered at the origin. Notice with the circle, we did those that were centered at the origin, but we also did those that were not centered at the origin. And we figured out where the center was and what the radius is. For the ellipse, we don't have to be able to do that. We only have to understand and work for this course with ellipses that are centered at the origin. The lines that go straight through the ellipse, both horizontally and vertically, are called the axes. There's a horizontal axis, there's a vertical axis. Each of the axes cuts the ellipse in half. And each half goes right on top of the other. If you notice on this one, the horizontal axis is longer than the vertical. The longer axis is called the major axis. The shorter one is called the minor axis. In this case, the major axis is along the x-axis. It's horizontal. And the minor axis is along the y-axis. On this one, the major axis is the vertical one, the one along the y-axis, and the minor axis is the one along the x-axis. So the longer one becomes the major axis, the shorter one is the minor axis. We're going to show how to graph an ellipse and also how to figure out what the axes are equal to. So first, let's talk about what this basic equation of an ellipse looks like. In the equation of an ellipse, you're also going to have an x squared and a y squared term, but there's going to be a number times the x squared and a number times the y squared. And those two numbers are not going to be the same number. That's why it's not the same side to side as it is up and down. But there is going to be in the equation of an ellipse both an x squared term and y squared term. The standard equation of an ellipse is x squared over a squared. It's not the same a as that, that's a capital A, plus y squared over b squared equals 1. Notice, in this case, if I ask you what's the coefficient of the x squared, it really would be 1 over a squared. The coefficient of the b squared is 1, of the y squared is 1 over b squared, because what's on the bottom, the denominator, is part of the coefficient. Sometimes our equations are written in what we call standard format. Sometimes they're not. We're going to look at how to figure out what the graph looks like when we have it in standard format, and then what to do when our equation is not given in standard format. We'll know that we're dealing with an equation of an ellipse in standard format. Again, it has an x squared over an a squared plus a y squared over a b squared equaling 1. It has to equal 1. So if I give you an equation that looks like this, x squared over 25 plus y squared over 4 equals 1, I will know this is an ellipse. Usually they'll tell you it's an ellipse, but you could recognize that it's an ellipse because there's an x squared and plus a y squared term, but the coefficients of the x squared and the y squared terms are not plain 1. They're either over something or there's either something under it, a denominator, or there's a number in front of it. And those numbers are not the same. If this was a 25 and this was a 25, yes, that would be a circle. But if these are different numbers, when the numbers are different, then the coefficients are different, what we get is not a circle, but an ellipse. Okay, the number underneath the x squared is what we call a squared. In this case, a squared is 25. And we know if a squared equals 25, that means that the a could either be plus or minus 5. Why is this number so important? Because it gives me the x-intercepts of the graph. It's telling me where this graph is going to cross the x-axis. Since a squared was 25, that meant the a was 5 or negative 5, so I go 5 to the right and 5 to the left. In other words, this is the point negative 5, 0, and this is the point 5, 0. Remember, on an x-axis, the x-intercept has a y of 0, and the numbers were either positive 5 or negative 5. The b squared is the number that's underneath the y squared. So the b squared in this case is 4. Now, just like we figured out the a, we can figure out the b. The b then has to be either plus or minus 2. 2 squared is 4, negative 2 squared is 4. What is the significance of the b? The b is the y-intercept. So we're getting 2 y-intercepts, positive 2 and negative 2. That means 2 up and 2 down. In other words, this is the point 0, 2, and this is the point 0, negative 2. Again, we can figure out the y-intercepts by looking at the b. And now I have 4 points. I'm going to connect those points with a smooth curve. And there's my ellipse. My ellipse comes out to be, it looks a little bit like a football. It's an oval shape, and that's what it should look like. If you notice in this one, the x-axis is the major axis, and the y-axis is the minor, the smaller one. I can even tell you how long the major axis is and how long the minor axis is. The major axis is starting, it's not going from the middle, it's going from one end to the other. It's going from -5 to 5. So the length of the major axis is 10. And the minor axis is going from -2 to 2. So the length of the minor axis is 4. And I have now given this equation in standard format, been able to discover what the graph would look like and what its major and minor axes are. Now, sometimes the equation is not given in standard format. What do we do when we have an equation not given in standard format? In other words, what would I do if I had something like this? Suppose I gave you 9x squared plus 16y squared equals 144. What if I gave you that equation and I said, I want you to draw the graph of this equation. And I know it has to be an ellipse because I see an x squared plus a y squared term, but the numbers in front of the x squared and the y squared are not just plain ones. Our coefficients are not, no problem, no doubt. The coefficients in front of the x squared and the y squared term are different numbers. This is definitely going to be an ellipse, but I can't say that what the x and the y intercepts are like I can do directly from that equation because this is not in standard format. So what I have to do is take this equation and put it in standard format. And the way we do it in the standard format, notice it has to be equal to 1. So I don't want 144 here, so I'm going to divide this by 144 because I know when I take 144 and divide it by 144, that's going to give me 1. But of course, if I divide one side by the 144, I have to divide the other side by 144 as well. In other words, take the number that's on the right side of the equation and divide every single term by that number, and then simplify. Now, I have a 9 over 144, so let's see if we can reduce that. 144 divided by 9 gives me 16. In other words, I can divide the top and bottom here by 9, and that'll give me 16, which is x squared over 16. Then I try dividing both the top and bottom by 16. So 144 divided by 16, that also works. This cancels out, and this gives me a 9. So in standard format, this 9x squared plus 16y squared equals 144 becomes x squared over 16 plus y squared over 9. It's sort of you interchange. The 9 goes under this because it was over here, and the 16 goes under here because it was in front of the y squared. When you are putting it in standard form, of course, this is the correct way, is just to divide everything by 144. Now that'll tell me that my a squared is 16, which means the a has to be plus or minus 4. That means my x-intercepts are 4, 0, and negative 4, 0. The b squared happens to be 9, which means that the b has to be plus or minus 3, which means that the y-intercepts are 0, 3. Remember, when you're doing y-intercepts, the x value is 0, and 0, negative 3. And again, once you know that, you can figure out what your graph of your ellipse will look like. I'm going to take one off and a test, and I'm going to give you one to try that's similar to what you might see on your final. Here's the question. I want you to give me the equation of the ellipse with the following intercepts. 4, 0, negative 4, 0, 0, 2, 0, negative 2. Now I'm going to give it to you as a multiple choice. So these are my intercepts of my ellipse. Here are the choices. Four x squared plus 16y squared equals 64. 2x squared plus 4y squared equals 8. 4x squared plus 8y squared equals 32. And D, 4x squared um, 16x squared plus 4y squared equals 64. Okay, I'm giving you this as a multiple choice. I gave you the question. I'm going to give you a few minutes to work it out. See, those are your intercepts. See which of those four equations is the equation of our ellipse. See if we can do that. I'm going to give you a few minutes to try it, to think about it. Graph. Draw a picture of what I have here. Maybe that'll make it easier for me to figure this out. Okay, so here's my graph. So it told me what the intercepts are. One intercept is 4, 0. 1, 2, 3, 4. The next one is negative 4, 0. The y-intercept, one is 0, 2. Here's 0 up 2. And this is 0, negative 2. And here's my graph. Here's my ellipse. Here's my oval. That's what it looks like, a little bit like a football. That's what it is. And we know that the standard equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. Okay, now I know what my a and my b is. My a has to be either plus or minus 4 because the a is the x-intercept, which means that a squared equals 16. Because 8 times a is 16. Negative 4 times negative 4 is 16. Positive 4 times positive 4 is 16. The a squared equals 16. The b are the y-intercepts, which are either plus or minus 2. That's what they told me, which means that the b squared has to be 2 squared, which is 4. So in standard format, the equation of this ellipse will be x squared over 16, that's my a squared, plus y squared over b squared, which is 4. That's going to equal 1. That's the standard equation. Unfortunately, they didn't give me the answers in standard format. So how do I compare the answer that I got in standard format with the answers that are not in standard format? So one thing is to take the answers and put them into standard format. It's not hard to put answers into standard format by just dividing the number by the number that's on this side. In other words, if I wanted to put this in standard format, I'd have to divide everything by 64. And then I'd reduce. 4 over 64 is 16. So it's x squared over 16. 16 over 64 is y squared over 4 equals 1. Actually, I don't even have to go any further. This has to be the right answer. If not, I would divide everything here by 8. This one I would divide everything by 32. And this one I would divide everything by 64. Don't make the mistake of saying, since that is x squared over 16 plus y squared over 4, that it's 16x squared plus 4y squared. That's the most common error. But remember, they get switched. If it's in standard form, the x squared is going to be over the 4 and the y squared is going to be over the 16. So that we can take each of them until we get to the right answer by putting it in standard format, because we're going to find the answer. How many people got A as their choice? Anybody do that? Okay. That basically takes care of the ellipse. I'm going to do one other example. I'm going to go a little bit out of order. Really, usually we do the parabola now, but I'm going to talk about something called the hyperbola, because that is something that doesn't require a lot of time. And we'll do the parabola on Tuesday, where we have to know more information about the parabola. The circle and the parabola, you have to know more information about. The ellipse and the hyperbola, you just have to know how to get them in standard form and how to graph them. So, the last thing we're doing today is we're discussing the hyperbola. And the basic equation of an hyperbola is ax squared minus by squared, or by squared minus ax squared. You again in the equation have an x squared and a y squared term. But if you notice in both the circle and in the ellipse, both, not only did we have x squared and y squared terms, but we also knew that the coefficients were always positive. In the circle, they both had to be 1. In the ellipse, they were different numbers, but they were positive. When it comes to a hyperbola, when we're going to have one of the coefficients being positive and one being negative. Now, the standard equation for hyperbola looks like this: x squared over a squared minus y squared over b squared equals 1. Or sometimes we have y squared over b squared minus x squared over a squared equaling 1. The standard format for a hyperbola is almost identical to the ellipse, except instead of having a plus between the two terms, we have a minus. That's why I have to give you both options, because sometimes the x squared term is the positive one, sometimes the y squared term is the positive. So for example, I might give you something like this: x squared over 25 minus y squared over 16 equals 1. This would be hyperbola. I know it's hyperbola because I have an x squared minus a y squared. I have x squared and y squared, but they're different signs. It turns out that you will not get both x and y intercepts. Sometimes you get your graph crossing the x-axis and not the y-axis. And sometimes vice versa, you have your graph crossing the y-axis, but then it doesn't cross the x-axis. It doesn't have both x and y intercepts, it just has one or the other. And you'll know ahead of time which one it has, because you get intercepts for the case where the coefficient is positive. In other words, here the x squared is positive, so therefore we're going to have x intercepts, which we'll get the same way we did for the ellipse. We'll take the a squared, which is 25, and that will give me that a is either plus or minus 5. The y squared is negative, so there's no y intercept. If I wanted to graph this, you don't have to know how to do a very exact graph. There's a lot more to the hyperbola than what we talk about here. We just do very basic. We have to know that what you're getting are two branches. I had mentioned this before when we talked about this on Tuesday. In this case, there are going to be two, what we call, I guess I'd call them vertical branches. We're going to have x-intercepts at 5. You're at 5, 0. And at negative 5. And what you get is two facing away curves. Sometimes these curves, they're sort of U-shaped. In this case, they're sideways U's, but sometimes they open wider, sometimes they open narrower. That how to figure that out is beyond the scope of this course. All you have to know is that you get two branches facing away from each other. Since the x squared is the positive one, you get x-intercepts. It does not cross the y-axis at all. If I gave you a question like this, suppose I gave you this example. I'm going to have to erase this. I'm giving you this example, y squared over 9 minus x squared over 36 equals 1. Okay, if we think about this, it's definitely a hyperbola because we have an x squared and a y squared term, but the sign in between them is negative. The y squared happens to be the positive in this case, and the x squared is the negative. Again, that's the sign that what we have is a hyperbola. In this case, it's the y squared that's positive, which means that we will get y-intercepts, but no x-intercepts. Because the x squared is negative, we can't solve it to get an x-intercept. How do we find the y-intercepts? Well, again, we do what we did before. We take the denominator, which is the b squared. B squared is equal to 9, because that's what this number is, which means the b has to be plus or minus 3. Remember, b squared is always under the y squared, a squared is always under the x squared. Even though the a squared happens to be 36, it doesn't help us in graphing this equation. We are only going to have y-intercepts and not x-intercepts. What are the y-intercepts? Well, one is positive 3. Also, you could call this 0, 3. And one is negative 3. And my graph are my two back-facing curves are going to be crossing like this, because they'll cross the y-axis, but they will not cross the x-axis. So that's what something like y squared minus x squared will look like. You might, I don't know if you can see this, that you can see how they give you different choices, and 2 of the choices are crossing the x-axis and 2 of the choices are crossing the y-axis. Obviously, this one would have to have one that's crossing the y-axis, and you'd have to look for it where it's crossing at the 3. One of them is crossing at the 3, and one of them is crossing at the 6. So you pick the one that's crossing at the 3. That's all you have to know about the hyperbola. Okay, so that leaves us with the only thing that we are left to do in terms of conic sections is the last type of conic section, which is called a parabola. That's what we're going to be covering on Tuesday. Don't forget that to get full credit for your test that's I posted on Delta Math, to get full credit, it has to be completed by Tuesday. Tuesday is the 17th. You have to have it completed by the Tuesday. We're getting close to the end of the term. After this chapter, we have 2 more, so we're in good shape. I want to have a good amount of time to review. And don't forget to keep track of the work and keep doing the work. Have a nice weekend. Does anybody want to ask me any questions?